Hello everyone. I'm going to be talking about the development of dry sanitation systems with biodigester as a clear alternative to modern flush-based plumbing systems. This is being presented as part of the CRSP research program. I'm part of the Department of Mechanical Engineering Technology. My name is Aryan Nair and my mentor is Professor Masato Nakamura. The purpose of this paper is to evaluate the downfalls of the flush-based sanitation system and to develop decentralized dry restroom systems which can potentially use a significantly less amount of water and can potentially provide a value-added product either in the form of energy or fertilizers. Restrooms in remote regions are often expensive to connect and they're very environmentally unsustainable. The goal is essentially to create a double task of trying to improve the imperfections in conventional toilet systems and while protecting the environment against the waterborne sewage pollutants on the other. This has massive applications even in the US when there's a shortfall of funding in maintaining public restrooms in remote areas. So essentially functionality, portability was a major factors being considered to ensure minimal parts and assembly was required for the assembly of the system. The biological principle behind the system is that it would essentially function as a family garbage processing machine. So the human waste has been decomposed directly through the use of slow rotation of the wood tips or sawdust in this box. This is further enhanced by adding anaerobic bacteria, and it's maintained at an ideal temperature of 80 to 90 degrees, and the entire thing should process within a period of 48 hours. So the bacteria being used is Clostridium, and it should be self-replicating, ensuring there is no need for supervision and that maintenance is not required. This is the functional working of the anaerobic bacterial system. So would break it down into a combination of carbon dioxide, methane, which is released to the atmosphere, using disinfected liquid and chlorination. And the image on the right shows a sketch of the biodigester tank, which of course consists of a chlorinator, a mounting bracket, a vent pipe, a top cover, a pan pipe, a P-trap, and an overflow pipe. For the purpose of the study, we have opted for several factors to consider while preparing a design specification. The surface area to volume ratio has been minimized to improve the contact area for the anaerobic bacteria. The water which was released in the study was found to be gray water, which means it's not drinkable, even though it can be used for other miscellaneous purposes. The sizes have been adjusted to meet the requirements of a single two-member household. The sizes can be adjusted with the same volume to surface ratio for a larger household, with mobility being the key concern while designing the system. The design is set at 540 mm by 1140 mm design specifications. The idea is that it should be able to be assembled, reassembled easily, which means the design is portable and it can be used in remote areas, hiking sites, and other difficult terrain. And the mobilities can also ensure that it's being used for specific events or for short-term housing projects. Another aspect which we considered was that the design is not connected to the electrical or plumbing grid, which allows for greater flexibility in usage. The wood chips don't need to be restocked since they only act as a catalyst, so the entire system is placed underground and it can stay without supervision for at least 3 years before restocking the wood chips. We are also considering environmental impact, which is one of the key aspects which we were looking at. The entire system is decentralized to consume a significantly lower volume of water than the existing systems, and the treated water will also be safe to use for farming or other miscellaneous purposes. The solutions we have implemented to counter the existing flaws in modern pumping systems is that we would release 20 to 50% less carbon embodiment compared to the conventional flush-based system across the entire system's life cycle. And we have also done studies on the efficiency, the carbon deposition, and the carbon embodiment to ensure the minimal environmental impact. The purpose of this design was essentially to examine how biodigesters can be designed and re-examined in an integrated sanitation unit or as part of a sanitation unit. So the study attempts to avoid pitfalls and create a design parameter which can be readjusted. So this can be based on the number of people or the usage, and while retaining the original research on the microbes, the surface area to volume ratio, and the optimal design. So this would hopefully provide important innovation towards more environmentally conscious designs in the field of sanitation. Thank you all for listening. My name is Arya Nair, and you can read more about my project on the greennniche.weebly.com. Have a nice day.